Okay, so today what we're going to talk about is calculating the average rate of change over a given interval, but we're talking mainly about quadratic functions. And so if you think about a quadratic function and its general shape, so the general shape of a quadratic function is our parabola. So it's different than a linear function because a linear function is a line. So a linear function has a constant rate of change. And as we can see here, quadratic functions have non-constant rates of change because it's not a straight line anywhere on the graph. But we can use the slope formula to find the average rate of change for a quadratic function over a given interval. So recall what the slope formula is. So we generally call it m. And the slope formula is taking the change in outputs divided by the change in inputs. So it's y2 minus y1 over x2 minus x1. And this is where the points x1, y1 and x2, y2 are on our line. So we can actually use this formula to figure out the average rate of change on a quadratic function within a given interval. So number one will walk us through this process. So what is it asking us? Calculate the average rate of change of the function y equals 2x squared minus 1. So here's our function. On the interval -1 less than or equal to x less than or equal to 0. So these are our inputs. These are our x values. Okay? So the first step to find the average rate of change is to find the 2 points that correspond to the endpoints of the interval. So the interval says that we're plugging in all the values between -1 and 0. So if we think about a number line, so all of these points, including the endpoints, those are all of our inputs. So those are all of our x values. So how do we find the ordered pairs of our endpoints? Well, I know for x equals -1, I can plug into our function. Y is equal to 2 times -1 squared minus 1, which gives us y is equal to 1. So our first endpoint is -1, 1. To find the other one, our other input is x is equal to 0. So again, we use our function to determine what the output will be. And you'll get y is equal to -1. So those are the 2 endpoints. So if you look here on the graph, we're looking at this interval for our inputs, and we found that these are the outputs. And when you have those 2 points, you can draw a line through them that allows you to calculate the slope. And so this gives you an idea of the average rate of change of the quadratic function. So we have our slope formula. Blue. M equals y2 minus y1 over x2 minus x1. It doesn't matter which one is x1 and y1 and x2, y2, so long as you're consistent. So for our purposes, let's say that the pink is x1, y1, and the red is y2, x2. So m is equal to -1 minus 1 all over Did I mess that up? I think I misspoke. So let's call this one x1, y1, x2, y2. Okay, so y2, I said, is -1 minus 1 over 0 minus -1. Sorry about that. When all the numbers are ones, it becomes very confusing, which is why it's always helpful to label your number so you don't accidentally mess it up. So Now you calculate the slope. You get negative 2 over positive 1, which gives you negative 2. So this is the slope of our orange line. This is the slope of the line that passes through our two endpoints. And this tells us that for the quadratic function, y equals 2x squared minus 1, there's an average rate of change of negative 2. It's decreasing on average by 2 throughout this function.